Hi, this is 2 Pointers in a Few Minutes by Study to Simple. Today we're going to be using two relatively simple problems to explore the different ways to use 2 pointers. So first up is toSum, and this problem is where, given a sorted array or data structure, we need to find the two numbers that add up to the target. So first up is toSum. Whenever we suspect a problem can be solved with 2 pointers, the first thing to think through is where to initialize the 2 pointers. Well, you might be tempted to just try a nested for loop, something like a brute force solution. Just compare every number to every other number. So if you're starting at 2, compared to all of these. But is this efficient? I don't think so, because each number needs to be compared against each number. And when this data structure gets very large, that's at least O of n squared time. So what's another approach? Well, where does it make the most sense to initialize the pointers? Well, initializing them at the start doesn't really make sense. So we know that the data structure is sorted, meaning the smallest element is at the far left and the largest element is at the far right. How can we use this to our advantage? Well, we're looking for a sum, so let's try to sum these two. We get 1 plus 17 equals 18, and if we remember, our target is 9. So 18 is much larger than 9. So now we think through the second kind of point that we need to always be thinking about is what's the condition to move one or both of the pointers? Well, right now our sum, 18, is much larger than our target, 9. So we should decrement at least one of the pointers, right? Well, it doesn't make sense to decrement left because we already know that's the smallest element. So the only logical one left to decrement is right. So let's go ahead and do that. What do we get? Well, we get 1 plus 9, which is 10, which is still larger than 9, but a lot closer. Okay, so let's try that again. Since we're still larger than the target, our sum is still larger than the target, so let's decrease right pointer. Well, what do we get now? Well, we get 8. So now we're smaller than our desired target, right? We got 8, we want to be 9. So what should we do now? Well, decreasing the right pointer doesn't make sense anymore because we want to get bigger. But should we increase the right pointer? Well, no, because we just came from that state, right? It doesn't make sense to increase the right pointer. So let's increase the left pointer. Okay, we increase the left pointer, and let's iterate and get that sum again. And what do we know? We are actually at the solution. So 2, 7 turned out to be the correct solution. So just to have a framework, how did we actually come to this solution? Well, we kind of thought through two main phases of the problem. First, we had to think about where to initialize the 2 pointers. For us, that was at the start and end of the array. Because the array is sorted, we know that the starting element is the smallest element and the ending element is the largest. So that kind of brings us to the second phase that we thought through, which was what are the conditions to move the 2 pointers? Well, this again ties to how the array was sorted. We moved left forward or to a larger element whenever our current sum was smaller than the target, and we moved right inward or to the left or smaller whenever our sum was larger than the target. So because 2 pointers is more of a general thinking pattern rather than a specific algorithm, that's why we have a second example problem for this thinking pattern. So valid palindrome is where, given a string, we need to determine if it's a true palindrome or not. So what is a palindrome? Well, simply put, a palindrome is a string that reads the same forwards and backwards. So ABCBA reads the same backwards ABCBA. So that is a valid palindrome. However, BED or BED does not read the same backwards, DEB. So that is not a valid palindrome. So referring back to the two things we need to think through whenever using 2 pointers, where should we initialize the 2 pointers? Well, let's think about what we're trying to validate, right? We want to validate if this is a palindrome. And the only condition that has to meet is that it reads the same forwards and backwards. So what does that mean for us? Well, it means that the first character reading frontwards and the first character reading backwards should be the same. So the characters at the left and right pointer should be the same. So that leads into the second thing we need to think about, which is how should we move the pointers, or when should we move them? Well, to be a palindrome, the entire word has to read the same, forwards and backwards. So with that in mind, how should we move the pointers? Well, whenever there's a match, so right now left is A and right is A, we should move them inwards, right? And check if they're still equal. And here we see that they're still equal. So we should keep moving. And then we hit our stopping condition, right? All the characters were equal. For example, here left is C, right is C. So we know that this entire string reads the same forwards and backwards. So this is a valid palindrome. And just to have a negative example that is not a palindrome, we'll quickly walk through this one. So left and right, the character is the same so far. So far this is looking like a valid palindrome. But what about here? Well, now left and right are not the same character. And so even with one mismatch, this entire string cannot be a valid palindrome. And here's the code for the 2 example problems we went over today. Thanks for watching.